Okay, this video aims to go through some of the basic ideas of trigonometry and how to solve some simple problems that you may come across. Trigonometry as a topic involves right-angled triangles to begin with, and it's about how the three sides link to the angles inside. So this angle down here, I'm using a symbol called theta. You may come across this in books, but you could also equally just come across letters like X or Y to represent the angle. But each of the three sides has a name dependent on where this angle is. Well, at least two of them will do. So this side over here, which is away from the angle, is called the opposite. This side, which is below the angle here or next to it, is called the adjacent. And this third side, the longest one, is called the hypotenuse. And the main thing you have to do in each problem is figure out the names of the sides, and particularly the two involved. So it's important that you're able to do that. The next slide goes on to look at the three main formulae that you're going to be using that involve these terms. In trigonometry, there are three main formulae that are used: sine, cos, and tan. And these are often represented using triangles as well, like this. Now, which of these you tend to pick to use really depends on you. I think more of you are going to use the triangles on the right eventually than the formulae that are on the left. But one of the main things you have to do in a question is pick one of these three formulae to solve a problem. And I'll go through how to do that. The way in which you pick it is dependent on this particular part of the formula and the two sides that are involved. So in any question there will be two sides involved in some way or other, and that's going to determine which one of these three you're going to use. Don't get too worried about what sine, cos and tan mean. Okay, that would take much longer to describe and explain, but it's just a case that you're going to use them, and you will need a scientific calculator or the calculator on the computer and the accessories and stuff in order to do this. But I'm going to go through an example in the next slide of how to use or select your formula to then solve a problem. So a typical problem could be one that involves a missing side. There are two examples of this I'll go through. This one here, we've got an angle of 35 degrees, two sides involved, one we don't know and one we do. And the main thing you do to start off with is you look at these bits of information and you think, well, what are they? What are these sides that I've been given or I'm being asked to work with? Well, the side which I've colour-coded yellow is the opposite. It is opposite the angle. And the side I've colour-coded red is the adjacent. It's next to it. And so if you look back at those three formulae, there's only one that involves opposite and adjacent, and that was the one that was called tan. So we're going to use this formula to then solve and work out how long the opposite side is of this triangle. Now on the left I'm going to show how to use the formula, and then on the right I'm going to show you how to use the triangle. So with the formula, the opposite, adjacent and the angle are all colour-coded here, and first thing you just need to do is to substitute the values in. Just put them in where they currently are. So you'll end up with tan 35 because the angle is 35 degrees. The opposite we want to know, so I've just put a question mark there, and the adjacent was 10 centimeters, so I've put that at the bottom. Now if you're confident of rearranging formulae, then it wouldn't take you long to figure out that the question mark is 10 tan 35, 10 times tan 35. So using a calculator, you can then work out a value and round it appropriately. And in this case, you'll get 7.54 centimeters. So it's just a case of substitute, rearrange, and then work out your answer. And you'll do that no matter what kind of problem. If you're using the triangle method, okay, and for tan, opposite, and adjacent, it's this TOA triangle. Because you want to work out what the opposite is, you normally cover up the opposite at the top. And because the tan and the adjacent are next to each other, in these triangles, when they're next to each other, it means multiply. So you'll end up with this shortened version down here, and again, colour coding where the values will go, you'll realise it's already rearranged for you. So here, putting the angle as 35 and the adjacent as 10, you'll be able to work out that the opposite is going to be 7.54. Again, most of you are going to probably pick the triangle on the right because it does the rearranging for you, so it's more efficient, a bit quicker. Now, the second kind of missing side problem I'm going to go through is one which involves the hypotenuse. Okay, so in this question again, if we identify the three bits of information that we were given, we've got the angle, we've got the hypotenuse now, the longest side being involved, and the adjacent. And I want to go through an example of how to find the hypotenuse because this will really explain why the triangles are important. Now the only formula that involves adjacent and hypotenuse is the cos formula, so we're going to use that, and on the next slide I'll go through how we use it to get the answer to the length of the hypotenuse. So again, we look at the colour coding and the information that we're dealing with, substitute in the values, and we end up with cos 35 equals 10 over this question mark, 10 divided by something. Again, if you're good at rearranging formulae, you could get the question mark on its own quite quickly. If you're not, this is going to make the triangle bit on the right much better for you in a moment. But rearranging this will give you the question mark, the hypotenuse that we want, is 10 divided by cos 35. Type that into a calculator and you'll get 12.21 centimeters. So the left hand side, I haven't explained the rearranging part because it's not really what I wanted to do, but you need to know that if you're really going to stick with this left hand side method. On the right, the triangle, you've got C, A and H. We want to know what H is for hypotenuse, so if you cover up the H, you'll realize that the A is above the C, and in these triangles that means divide, A divided by C, or cos, and so we'll end up with this already rearranged formula ready to go. And if we look at the values that we're putting in, we're able to get that the hypotenuse is 10 divided by cos 35 straight away. No worrying about rearranging a formula or doing anything too drastic. To put those values in a calculator, you'll get the same answer again of 12.21, and you're done. So hypotenuse problems can be trickier to rearrange, but if you use the triangle method, that won't be an issue at all. Now the final problem I need to go through is how to find a missing angle. So in this question here, we've got an angle we're trying to work out, and we're told the value of 2 of the sides. You'll always get 2 sides to work with. If you get all 3, that means you can pick what you want, but you need 2 of them. So in this case, the 2 sides we're dealing with are the opposite, it is opposite the angle, and the hypotenuse, the longest side. This means we've got to use sine now, because it's the only one that has those 2 sides involved. If we use the formula, these are the values, colour-coded again, put those in, we end up with sine of the angle is 9/15. Now, this is where the tricky part comes, because you've got to get the angle on its own. So we need to find what the inverse of sine is. Now, because sine is a function that we're just using anyway, on the calculators the inverse sine is written usually above the key. And if you look there, you'll find that the inverse sine is sine to the power of -1. Now, whether you get this next part or not, you have to do it and you have to use it. But if I use the inverse sine on both sides, it will cancel out sine on the left to leave just the angle. And on the right, I'll have sine to the power of -1 of 9/15. Now, put that into a calculator and you'll get your answer rounded appropriately. But it's just that step. That stage there, I think, is going to be the tricky part for most of you, of why does that happen, why does it work? But if you do the same to both sides of an equation, it will balance and it's fine, and that's the part there that I think you need to think about. Now, if you're thinking that using the triangle will make this better or quicker, it won't. You're still going to end up, if you covered up sine, you've got opposite divided by hypotenuse. It doesn't explain or show that you've got to use inverse sine at all, so it can be a bit unhelpful in that way, but it is quite useful to use to memorize the formulae and get things in the right order. So some general steps, some of the ideas that you need to follow in solving a problem. Firstly, identify the sides involved, particularly the 2 main sides that are in the problem. Select the appropriate formula or triangle using the sides that you know that are involved. Substitute values and rearrange if you're using a formula. If you're using the triangle, the rearranging will already be done, and then you substitute in the values. Calculate and round your answer as appropriate at the end. Okay, now hopefully that's a fairly useful video on how to solve some basic trigonometry problems. Thank you, and feel free to leave me some feedback.